Today we cover the best section of the whole semester. Why is this the best section of the whole semester?
Because it deals with money.
One, because it deals with money. And two,
It's applicable.
that's true.
It makes math have a real world meaning.
It makes math have real meaning, okay. And then three, the one I was thinking of.
Addition, subtraction.
No, better than that. It's the last section. This is the last thing we're going to cover this semester. That makes it the best. All right, so we're going to be dealing with money. When you deal with money, one of the most common things you deal with is interest. Anybody remember the formula for what's called simple interest? All right, the formula for simple interest is I equals PRT. What does I stand for? Interest. Okay, that's an obvious one. What's P? Not percent.
Price.
Not price. Principal, that's correct. What does principal mean? How much you started with. What's R? R is the interest rate, and T is time. All right, so you invest $1,000 at 3% simple interest for 1 year. How much is in the account at the end of the year? Well, we simply use our formula. The interest we're going to earn, I, is the principal. What's the principal? $1,000. Our rate, 3%. Our time, 1 year. It's 1,000 times 0.03 times 1. How much? 30. So you earn $30 in interest for the year. So how much is going to be in your account? So the answer is your future value, usually written as A, is 1,030. Now, the reality is very few places where you invest money actually pay simple interest. What do most banks and other places do when you invest your money? When do they pay interest?
Mine has to be over X amount. It has to be greater than X amount to even earn interest.
All right, so if you have certain checking accounts require you to maintain a minimum balance. So $1,000 might not even be enough to earn interest. That's true. But if you earned interest, quite often banks pay interest quarterly, or maybe they pay it monthly. Those are probably the most common too. What do I mean when I say the bank pays you interest quarterly? How often do you earn interest? 4 times a year. All right, so same problem. You invest $1,000 at 3% interest, compounded quarterly. How much will you have after 1 year? All right, so we start with $1,000. What happens at the end of the first quarter? Well, the bank pays us some interest, don't they? How much interest do they pay us? They pay us 0.25%. So the interest we're going to earn is going to be P times R times T, which is the principal, which is the $1,000, times the rate, which is 3%, but time is not a full year. How much time has gone by? A quarter. So they pay us 0.25%. So I grab my calculator. 1,000 plus 0.03 over times 0.03 over 4. They pay us $7.50. So at the end of the first quarter, we'll have $1,007.50 in our account. Okay. What's going to happen at the end of the second quarter? Well, they're going to pay us interest again, aren't they? So we're going to have the $1,750, and they're going to pay us our interest. Our interest is 0.03 times over 4, 3%, but only for a quarter year. So that's going to be 1,007.5 times 0.03 divided by 4. They're going to give us $7.55. Now notice my answer came out to be 7.556, and I rounded it to $7.55. How come? Because that's what banks do. Banks don't round up. So they're going to pay you another $7.55. So how much will we have? We'll have 1,015.05, I think. I take my 1,750 and I add my 755. And we keep going. At the end of the third quarter, we're going to have this 1,015.05 times 0.03 over 4. 1,015.05 times 0.03 over 4. We're going to get another $7.61. So 1,015.05 plus 761. We have $1,022.66. And finally, at the end of the first year, we take the $1,022.66. We earn some interest. In fact, we earn $7.66. And so our final amount at the end of the year is $1,030.26. Questions on that? Notice that compounding quarterly is better than simple interest. Why is compounding quarterly better than simple interest? Well, if you were earning simple interest, how much did you have at the end of the first year? $1,030. Compounding quarterly, how much money did you have at the end of the first year? You gained. I don't know, a lot. You only gained 26 cents. But it's still better, isn't it?
Should technically be 32.
I did my math wrong?
Yeah. And at the end of the third quarter, you changed it from 1,022.66 to 23.66.
You're right, I did. So I missed 6 cents. So that should be 32. All right, even better. Bank error in your favor. Collect 6 cents. Gain an extra 32 cents. What if I asked you to take that $1,000 and you're going to leave it there for 5 years? Would you want to keep going and doing this over and over and over and over again? For 5 years?
No.
I hope not. There's a better way. All right, here's what we're going to do. We're going to come up with a formula. At the end of the first quarter, how much money did we have? Well, at the end of the first quarter, we would have our original principal. That's how much money we started with. Plus, we would earn interest. And so to find our interest, we took our principal times our rate, and we divided by n, where n was, in our example, n was 4. Why was n 4? Because I had chose to compound quarterly. All right, I'm going to factor that. I notice that they have a p in common. So I'm going to factor a p out. And I'm left with p times 1 plus r over n. Now, what happens at the end of the second quarter? Well, I earn interest. But at the end of the second quarter, what was my principal? How much money was in my account? It's not just P anymore, is it? Why is it not just P? It's the total with the first quarter interest. And the total with the first quarter interest was this formula here. So I'm going to have P times 1 plus r over n. That's my principal. Then I'm going to earn interest. And now my principal is not just P, it's P times 1 plus r over n. And I add my interest. To get my interest, I multiply by r over n. Now, once again, I'm going to factor. And I notice that I have a P in common, and I also have a 1 plus r over n in common. So I factor out my P times 1 plus r over n. And then what's left over? Well, everything factored out of this first term. So there's a 1. And then I've got my plus r over n, which I can write as P times 1 plus r over n squared. And now I think we start to see a formula. What's going to happen at the end of the third quarter? It'll be cubed. And what's going to happen at the end of the fourth quarter? It'll be a fourth power, so on and so forth. So if I wanted to do this for 5 years, how many quarters is 5 years? It would be 20 quarters. So I would need a power of 20. All right, so what this gives us what's known as the compound interest formula. And it's A equals P times 1 plus r over n raised to the nt. So our problems are going to look like this. You invest $1,000 at 3% interest, compounded quarterly. How much will you have in 5 years? all you need to do is plug in all your numbers. A stands for the amount of money you're going to have in the future. That's what we're trying to find. So that's going to be A. P is the principal. What's the principal? $1,000 times 1 plus our interest rate, 3%. I write that as 0.03. Divided by N. N is 4 because we're compounding quarterly. Raised to the N, which is 4, times 5 because we're doing it for 5 years. And then I just grab my calculator. So I'm going to have 1,000 times 1 plus 0.03 divided by 4 raised to the, now this is where people make the mistake, I can either type in 20, because 4 times 5 is 20, or if I'm going to type in 4 times 5, I need to put it in a set of parentheses. And people will forget that set of parentheses. You got to make sure your exponent's in parentheses, so you do that first. I hit enter. At the end of 5 years, I would have $1,161.18. Questions on that? Well, we saw that compounding quarterly was better than earning simple interest. What would be better than compounded quarterly? Compounded monthly. All right. So same problem, except now compounded monthly. So now, in other words, they're paying you interest at the end of every month. And that's fairly common of a savings account. Savings accounts quite often pay interest monthly. Checking accounts tend to be sometimes monthly, sometimes quarterly. Depends on your account. All right, so we would have our amount in the future is 1,000 times 1 plus 0.03 divided by 12 would be the big difference. Dividing by 12 instead of dividing by 4. And then instead of 4 times 5, we're going to have 12 times 5. So once again, we grab our calculator. 1,000 times, parenthesis, 1 plus 0.03 divided by 12. Raised to the 12 times 5 is 60. You earned more interest. Did you earn a lot more interest? Some change. And remember, this is over 5 years. So over 5 years, you gained an additional, what? 43 cents? So you gained about 8 cents a year. Raking it in good, aren't you? What would be better than compounded monthly? Weekly would be better. What would be better than weekly? Daily would be even better. What would be better than compounding interest daily? Hourly. And you could keep getting more and more and more, couldn't you? And eventually we come up with a formula called compounded continuously. And the formula for compounded continuously is A equals P E to the RT. Well, E is something new. Anybody know what E is? E happens to be a number. And E is a number like pi. It's irrational. On your calculator, you might notice there's an E button. So if I do E raised to the 1, that gives me an approximation for what E is. E is about 2.718281828. It looks like there's a pattern there. It looks like it's going 18281828, but it really doesn't do that. If my calculator could show more decimals, you would see there's no pattern. So E is an irrational number, similar to pi. It goes forever no pattern, no repeats, so on and so forth. So if I give you the same problem, $1,000, 3% interest, compounded continuously, that would be the most possible interest you could earn. So you're earning interest all the time at every possible partial second even. And our amount in the future would be 1,000 times e to the 0.03 times 5 for 5 years. And we would grab our calculator and we would go 1,000 times e, we use that e button, 0.03 times 5. And we would have 1,061.83. That would be the most possible interest we could earn in 5 years at 3% interest. Now, unfortunately, I don't think there's any bank in the world that pays interest compounded continuously. But this still is an important formula. There are some things in life that are very, very close to continuous. And one of them is population. So the same formula is very often used for population growth. If you look at a culture of bacteria and let it grows almost continuously because there's so many of them. And so you'll see formulas used like this quite often to model other things. Doesn't make a lot of sense with money, but it's used for other things. We won't use it in this course. You'll do a lot more with this next semester if you take Math 1215. Questions on that? All right. Would you rather earn 2% interest compounded quarterly, or 1.8% interest compounded monthly? Which one is better? Monthly, even though the interest rate's a little bit smaller? Maybe. All right. So, in general, monthly is better than quarterly. However, your monthly interest rate's a little bit higher than your quarterly interest rate's a little bit higher than your monthly interest rate. So, which one's better? How would you figure it out? Would it matter how much you're investing? No, it really wouldn't. So let's pick a number. Let's pick a real easy number. $100. All right. So let's say we decide we're going to take $100 and we're going to invest it into both of these accounts, and we'll just see which one has more money in it, won't we? All right. So account number 1. The amount after, how many years do we want to let it sit in the account? Let's just make it 1 year. Make it real easy for ourselves. So on account number 1, we start with $100. We're going to have 1 plus 2% compounded quarterly raised to the 4 because our T is just 1. We're doing 1 year. All right, so that's going to be 100 times 1 plus 0.02 divided by 4 raised to the 4. And even though the bank would round it off, I'm going to go to 1 extra decimal point just in case I need it to see which one is better. So this 102.015, because I think the answers are going to be close. So I'm going to go to an extra decimal point in case I need it. All right, let's try account number 2. Account number 2, my amount in the future would be 100 times 1 plus 0.18 divided by 12 raised to the 12. 100 times 1 plus 0.18 divided by 12 raised to the 12. Oh, that's not right. It's not. It's 0.018. 0.18 would be 18% interest. That's not a fair comparison. Put a 0 in there. 101.815, I guess. So 3 decimal places. So which one's better? The 2% interest was better, wasn't it? You would have more money. Okay, so what this is known as, this is called the effective rate. You're being told you're earning 2% interest compounded quarterly. What interest did you actually earn for the year? If your money was only compounded once, you actually earned a little bit more than 2%, didn't you? Because what would 2% of $100 be? 2% of $100 is only $2. So your effective interest rate, you earned the 2%, but you actually earned a little bit more. And then this one is 1.8%, so you should have earned $1.80 if it was just one time a year, but you actually earned a little bit more than $1.80. That's called the effective rate. And there's actually a formula for effective rate. And the effective rate formula is 1 plus r over n to the n minus 1. All right, so you'll see things like this. If you ever go to buy a car or if you ever get a home mortgage, you'll see things like your mortgage has a 4.5% interest rate, compounded monthly. So they will give you that information. And then, almost immediately following, they will tell you the effective rate. And so what they're telling you is, you're not really paying 4.5% interest. You're really paying more than 4.5% interest. How come? Because you're paying that 4.5% interest every single month. So that interest adds up. What is the effective rate? So the answer would be 1 plus 0.045 divided by 12 raised to the 12 minus 1. So you're not really paying 4.5% interest. You're really paying 4.93% interest. That's how much interest you're paying for the year. Questions on that? Many, many years ago, I went to refinance my house. And we were going through the paperwork with the bank. And the bank gave us numbers like these. The lady said, your mortgage is 4.5% interest. And then she read the next line, says effective rate 4.93% interest. She said, I really don't know what that means. I really don't understand why those numbers are different. And I almost backed out of the deal right then and there. I mean, if the lady in charge of doing my mortgage didn't know the difference between interest rate and effective rate, I was not very confident in the bank. However, that bank had by far the best interest rate. So I went with them anyway, even though I thought the lady in charge was not very good. I did explain to her what it meant. I wasn't sure she was happy about that, but I gave her a little math lesson. Wrote right on my mortgage papers. Anyway. All right, last kind of problem you're going to see in this section. You want to buy a car. 3 years from now, you want to buy a car that costs, how much is your car going to cost? $62,000.
Buy a brand new Model S.
Buy a brand new Lexus or something. $62,000. How much do you need to invest today if you can earn interest? If you can earn, what's our interest rate going to be? Make up a number for me.
3.6.
3.6% interest. Compounded. How often are we earning interest? Quarterly. All right. A equals P times 1 plus R over N to the NT. Of all those letters, which one are we trying to find in this problem? P, we're trying to find how much do we have to have today. That's our principal. Well, then what's A? $62,000. Equals our principal, that's what we're trying to find, times 1 plus, our interest rate is 0.036, divided by 12, because it's compounded quarterly. N is 12, and we're doing this for 3 years. 12 times 3 is?
Wouldn't quarterly be 4?
Oh, quarterly is 4. I was trying to make it better for us. Quarterly is 4, so N is 4, T is 3. 4 times 3 is 12. So how am I going to get the P all by itself? Well, this is just some number, isn't it? Not a very nice number, it's an ugly decimal. But I have P times a number. To get the P all by itself, I just have to divide by this number. So my answer is P equals, I grab my calculator, $62,000 divided by 1 plus 0.036 divided by, this should be 4 here too, shouldn't it? Because we're compounding quarterly. I wanted to go monthly, I guess. Raised to the 12. So we need to have a mere $55,679.80 today. So if we have $55,679 today, and we invest it, 3 years from now we can walk in and pay for that car brand new, pay for cash. What's the moral of the story?
Buy a cheaper car.
Not buy a cheaper car. Well, yeah, probably is a good idea too.
If you have that much already,
If you have $55,000 today,
settle and buy ice cream or gummy bears. Whatever.
if you have $55,000 today, you might as well go buy that car today. And what are you going to do about the other $7,000 that you take out a loan? Yeah. So, this is why very, very few people pay cash for a car. Why? How come people don't pay cash for a car? Well, because if you're saving up and you want to buy a car 3 years from now, you're going to have almost the whole price of the car ready today. So what do most people do?
Pay monthly with the car.
You get a loan and you pay monthly. That's what most people end up having to do. Certainly what I've always had to do. I've Well, except for beat up junker car that I bought for my son. That one I paid cash for, but it wasn't very much. It wasn't anywhere near $55,000. Okay. Here's another scary situation. 3.6% interest. Can you earn 3.6% interest today? Probably not. Last time I looked, my savings account was paying 0.03% interest. So if it's 0.03% interest, what number would I put in here? 0.0003. So 3.6% interest really isn't very high, but interest rates today are so incredibly low that there's no way you're going to get 3.6% interest. You might get a mortgage for 3.6%. That would be a good mortgage. Right now they're running somewhere between 4.25% and 5% generally. But you might be able to find a 3.6% interest somewhere. You owe $15,000 on your credit card. You've made some bad life choices. Because the interest rate is, what are interest rates on credit cards usually? They're quite often up in the 20s. A good deal on a credit card might be like 17 or 18% interest, but they're quite often up in the 20% interest rates. So the interest rate is 21%. Compounded monthly. You don't pay for 3 months. Sometimes they'll give you a couple months if you miss your payments. You miss only 3 months. How much money do you owe now? Well, A equals P times 1 plus R over N to the NT. The amount we're going to owe. We started owing $15,000. 1 plus our interest rate is 0.21 divided by monthly. That's 12 to the 12 times, what's my T? Not 3. You got to be careful there. That's a common mistake people would make. T is always time, but in what units? Time in years. And I only gave you 3 months. So I won't use 3 there. What will I use? How long is 3 months? It's a quarter of a year. So that's a very, very common mistake. People will use 3 right there on this problem. It shouldn't be 3, it should be a quarter. All right, so that's $15,000 times 1 plus 0.21 divided by 12 raised to the 12 times a quarter is 3. So by not paying for 3 months, you now owe an additional $800. What's the moral of the story? First off, don't have $15,000 in credit card debt. Credit card debt is probably the biggest killer that people have. Credit card debt and student loans, unfortunately. Credit card debt's an absolute killer. It's an absolute killer because the interest rate is so high. $800 over 3 months, that's a lot of money. The other moral of the story is, if you can get into the racket, owning the credit card is a wonderful deal. Being the credit card company is a wonderful deal. How come? Because you're earning 21% interest compounded monthly. That's a lot of money. So that's why most banks offer credit cards. Credit cards is one of their biggest money makers. They make more money off the credit cards than they do your savings account. It's even better than that if you're the credit card company. Do you know why? What happens every time you use your credit card? The credit card company takes the money, that's true, and then they give it to, let's say you use your credit card to buy gas. So what happens? Well, the gas station gets paid, don't they? But they don't get the entire amount. Quite often what happens is the credit card company takes 2% right off the top, depending on the type of card. I think Visa and MasterCard take 2% right off the top. I think Discover takes 3%. So if you spend $10 on gas, the gas station doesn't get $10. They lose a certain percent. The credit card company takes money right away just for you using their card. And then they turn around and they charge you 21% interest. So the credit card companies almost can't lose. They get money when you spend it, and they get money when you pay it. So when you see those credit card companies, when they say they're giving you double cash back, are they really doing you any favors? No, not much. Because they give you such a small interest rate, they're not really helping you very much. Anyway, credit cards are a bad thing. So, lesson for today. If anything else, don't run up a lot of money on credit cards. It's very, very difficult to get out from under. Questions on anything?